Hey Vsauce, Michael here. But who is Michael? Of course, what you call Michael is just an amalgamation of trillions of cells and atoms. I am an individual. Despite all the bits and pieces that make me, I'm still just a single organism. A group of organisms of the same species makes a population, a group of populations in one area makes a community, and once you add in all the non-living or abiotic factors, you have an ecosystem. Several ecosystems with similar characteristics form a biome, and all the biomes on Earth combine to form our biosphere.
Bill Nye the Science Guy.
Do you ever wonder why not all members of a species look the same? Well, in order for a species to be successful, it needs a high level of genetic diversity. You might think that after millions of years of evolution, all members of a species would look more or less the same, but that's not the case. You see, the more variance in the gene pool a species has, the more likely it is to adapt to changes in their environment. A species with little genetic variation would be put at a greater risk of extinction from things like changes in the food supply, a minor natural disaster, or hereditary diseases. But even when a species is successful, it can't just keep multiplying forever. Exponential growth just isn't sustainable. Instead, when we observe population growth, we see logistic growth. This is due to limiting factors in the environment. Eventually, there just won't be enough resources for the population to continue growing. It will hit a point and then maintain at that level, called the carrying capacity. I'm at Missing Persons National Park to observe some of the wildlife of the area. Particularly, I want to focus on some of the black bears that call this area home. Now there's one right there behind that tree. I'm not sure if you can see him, but he is definitely there. These black bears are what's known as a keystone species. Now, that's any species who plays such a vital role in the ecosystem that it would completely collapse without them. Think of the coyotes in Yellowstone. Once they dwindled in population, the deer they used to hunt grew in population and ate much of the plant life of the area. Now this spelled disaster for many species that called Yellowstone home. Once coyotes were reintroduced, it started a chain of events that allowed the ecosystem to flourish once more. Now another species you'll find in this area is the brown marmorated stink bug. These guys are not a keystone species. In fact, they're an invasive species. Originally native to Eastern Asia, they first arrived in the United States sometime in the 1990s and have had a negative effect on ecosystem health and biodiversity ever since. Hey kids, today I'm going to educate you on the wacky world of species interactions. Now, based on my sister's pet guinea pig, you may think all animals do is sit around all day, but that couldn't be further from the truth. Take a walk through your local ecological oasis and you'll see tons of competition, predation, and symbiosis. What do these mean? Allow me to explain. Competition is pretty self-explanatory. Members of a species will fight over food, territory, and mates. Predation is also something I'm sure you're familiar with. One animal eats another, and that's the whole interaction. The cool interaction is symbiosis. It's so cool that it gets its own subset of categories: mutualism, commensalism, and parasitism. Think of pollinators like bees. They get nectar to make honey, and the flower gets its pollen spread around. Both organisms benefit. That's mutualism. What about those fish that suck off sharks? The fish get to eat scraps from the shark, they're benefiting, but the shark is pretty much unaffected by the fish. Only one species benefits, that's commensalism. Parasitism is the nasty one. Think of a tick latching onto your dog, or a group of middle schoolers standing directly in the center of the hallway. One organism benefits, one organism is harmed. Parasitism. Now, you might be asking, what about relationships where one organism is harmed and one is unaffected, or when both are harmed? Well, that's called cruelty, and the only species capable of doing that are humans, and chimps sometimes, but whatever. I received a call about an aggressive male posing a threat to humans in the area. Hopefully, I'll be able to safely capture and relocate. There he is. Now, he's a heterotroph, meaning that he can't make his own food like plants, bacteria, and other autotrophs do. His cells can't undergo photosynthesis, meaning he has to eat other organisms for food. And if I'm not careful, I could be his next male. I've set a state-of-the-art trap to try to capture him, and let's see how it goes. I'll take it from here. Greetings, children. Captain Biology here. Now, that wild beast you just saw has a pretty high trophic level. An organism's trophic level tells you more or less where they lie on the food chain, or food web if you want to use your fancy AP biology knowledge. Producers lie at the bottom, which are eaten by primary consumers, which are eaten by secondary consumers, and so on until you reach the final, predator-free species of an ecosystem. You can visualize the flow of energy by using a pyramid of energy. 10,000 joules stored by producers at the bottom becomes 1,000 joules stored by primary consumers, which becomes 100 joules stored by secondary consumers, and so on. The energy decreases due to metabolic processes that release heat while breaking bonds between molecules. You know, after listening to all this wildlife talk, it really makes me appreciate Mother Nature. Eutrophication, pesticides, chemicals, the greenhouse effect, acid rain are all ways that you humans ruin your planet. It's a shame, but 70% of emissions come from just 100 companies, so do whatever you want and you'll be fine. But now I'm afraid it's time for me to go, kids. Miss Mac is about to try to pronounce the word corroborate. Remember, love with your heart. Use your head for everything else. Captain Biology.